Hi, in this video I'll go through integrals of sine and cosine, their powers and their products mixed together. There will be four types of integrals that I'll talk about in this video. Number one is a power of sine or a power of cosine or a multiplication of them, a product of them, where at least one of the powers is odd. And number two is the rest of it, which is power of sine or cosine or their product, where all powers are even. Both powers are even. Well, within that, there's a shortcut that I'll talk about. That will be number three. A shortcut in a case where you have an integral of sine to the nth times cosine to the nth, where the power n is the same for both, where the powers are equal. And finally, the fourth case I'll talk about is when the sine and cosine are of different angles. In this video, I will be assuming that you know a few things already. First of all, I assume that you already know the formulas for the basic antiderivatives of sine and cosine. I also assume you already know some basic trig formulas. So first of all, I'll assume you know the Pythagorean identity, the one that says sine squared x plus cosine squared x equals 1. And then from there, we can solve for sine squared x, and you got sine squared x is 1 minus cosine squared. Or we solve for cosine squared, then we get cosine squared equals 1 minus sine squared. So those are the two versions that will come up in this video. I also assume you know the cosine double angle and how to get the square out of it. So cosine of 2x is equal to cosine squared minus sine squared. And then if you plug in the Pythagorean, then you'll get that is the same as 2 cosine squared minus 1 or 1 minus 2 sine squared. Well, from that, if you solve for cosine squared, you get a formula for cosine squared that is in terms of cosine 2x. And a formula of sine squared that's also in terms of cosine 2x. What that will help us is we have something that's squared, and then after we do this, it's no longer squared. I will also assume that you know the product to sum formulas. These come out of the sum of angles and difference of angles formulas. And when you play around with it, you get these formulas. What happens is that if you have a product on one side, you go through this formula, it becomes a sum, and an integral of a sum is easy. An integral of a sum is just the integral of one plus the integral of the other. And finally, for purposes of the shortcut that I was talking about, I assume you know the sine double angle formula. Sine 2x is equal to sine x cosine x. You can see that this way, if both sides got raised to some power n, then on the right you have sine to the nth of x and cosine to the nth of x, and that could be combined together into a single sine to the nth of 2x. Let's now go into the first type of integral, and that is the product of powers of sine x and cosine x, where at least one of the powers is odd. Let's do this integral. Integral of cosine to the fifth sine cubed x dx. The key to doing an integral where at least one of the power of sine or cosine is odd is to separate one power out. And then that leaves the rest of it even. I'm going to do that with sine cubed for now. I can break it into sine and sine squared dx. Well, because it started out odd, 3 is an odd number, I take out 1, I have 2 left, that's an even number. That means there is a sine squared inside of it, or in this case, just sine squared. Well, sine squared can be written as 1 minus cosine squared. So what I have is a sine x dx, a 1 minus cosine squared, and a power of cosine. I can do u substitution now, because I can recognize that this is du if u is equal to cosine. That's the key. The key is to take one of the odd powers and separate out one of them. Well, right here we have cosine fifth and sine cubed. They are both odd, so I could choose either of them. In general, it doesn't matter which one. One of them tends to be a little bit easier than the other. I'm going to do one. I'm going to do cosine fifth, actually. I'm going to do cosine fifth. You should do sine cubed. And that way, after you compare, you can see which one is easier. And then you can kind of, figure out in your mind for yourself how you choose the easier one to make life easy. All right, so I take cosine fifth and I separate out one of the cosines. That leaves cosine of fourth and sine cubed and the dx. This one looks like the derivative of sine. So that means I want to change the rest of them into just sine. Well, this is already sine. This one, cosine to the fourth, is the same as cosine squared squared. And now you see the key in separating out one of the odds so that the rest is even. The rest is even, so I can have the cosine squared inside like that. And cosine squared is 1 minus sine squared. So if I do a u substitution with u is equal to sine, and du is going to be cosine of x dx, then I'll have integral of cosine to the fourth becomes 1 minus u squared squared. Sine cubed becomes u cubed. Cosine x dx becomes du. It's just algebra now. The integrand is now just a polynomial, and I know how to do polynomials. Multiply this out and integrate. And then I take sine x, I substitute back. This becomes 1/3. There we go. For this type of problem, where there is a power of sine or cosine that is odd, these are the steps. First, pick an odd power and separate out one of them, either sine or cosine. Do u substitution where u is equal to the other function. So if in step 1 you separate out the sine, then u is equal to cosine. If in step 1 you separate out the cosine, then u is equal to sine. Use the Pythagorean identity to replace into the u function and then integrate as a polynomial. All right, let's do the other type of power. When you have sine, cosine, and neither of them is odd, that means they are both even. For cases where sine and cosine are both even power, the key is to use these conversions. These conversions come from the cosine double angle formulas. And what they do is you start with a square, but you end up with cosine of double the angle, but no more squares. I'm going to do two examples. The first example is this one, integral of cosine to the fourth. I'll rewrite it as the square of cosine squared. And the inside of that square, I'm going to use a double angle formula, end up with 1 plus cosine 2x over 2. That's the cosine squared on the inside. Square it up. I do the squaring. The denominator, 1/2 squared, is 1/4, so I'm going to put it outside. The numerator is 1 plus, you're going to use the square of binomial. All right, the first term, no big deal. Integral of 1 is x. Second one, integral of cosine is some kind of sine. I still don't know how to do this. Cosine squared of 2x. I'm going to do the same thing again. I'm going to apply the same double angle formula again. This cosine squared will become 1 plus cosine, and then the angle is doubled up, so it's now 4x divided by 2. Now I can integrate. Integral of 1 is x plus 2 times. Integral of cosine 2x is sine 2x over 2. I'm going to show you how I did that. There are two ways to do this. For me, I do it in terms of chain rule in my head, but it may not be as easy for you. So let me tell you my way first, and then I'll show you a different way. My way is I know it's some sort of sine 2x. But sine 2x, derivative of it is going to be cosine 2x. That's good. But then it'll also be multiplied by 2 by the chain rule. So in my head, well, I'm going to have to divide by 2 to get rid of that 2. And so that's where I get this over 2 here. That's how I think about it. It may not come normal for you or come natural for you. A different way is to mentally think that you're going to do a u substitution here. Then it's integral of cosine of 2x dx is integral of cosine u, but then du is going to be 2 dx. So dx is going to be du over 2. And that's where that over 2 came from. So yeah, one way or the other, or you can slow down and actually carry out the u substitution. If you do carry out the u substitution, it'll go like this. For the rest of the video, I'm going to just go ahead and do that in my head and divide by that coefficient of x. Plus, integral of 1/2 is x over 2. And 1/2 integral of cosine 4x is sine 4x over 4. And then plus c. Combine like terms. Cancel these two. Combined like terms, x plus x over 2 is 3x over 2. And multiply by the 1/4 on the outside is 3x over 8. Plus sine 2x and times the 1/4 from the outside. Plus 1/2 times 1/4 is 1/8. And then times the 4 on the outside is 1/32. Right, so 4, 2, and 4 multiplied together is 32. And sine 4x on top plus c. One more thing I want to say. Some people insist on those parentheses. I don't. Usually don't, but sometimes I do, especially if it could be ambiguous. So in this case, I'll put it around just to make sure we understand that that's what it covers. But I also want you to know that it's really not that necessary all the time. All right, let's do another example where I have 2 of these squares, even powers. Or if I tap 2 of them, I apply both of them. I plug in the double angle formula for cosine squared. I plug in the double angle formula for sine squared. This is 1 plus cosine 2x. This is 1 minus cosine 2x. Now I do the algebra. The denominator is 1/2 times 1/2, so it's 1/4. I'm going to take it outside. All right, the numerator. The numerator, you can distribute and multiply FOIL. Or you can look at it and recognize that it is the difference of squares formula. So it's equal to 1 minus cosine squared of 2x. Once you've arrived here, first thing is you may be wondering, did we even make any improvement at all? Because we started out with squares and we ended up with squares. Does that help? Well, yes. Because actually you started out with 2 squares. So the power over here is actually a power 4 equivalent. Whereas now we're down to power 2. So yeah, every time we apply these double angle formula, the power got cut in half. You may also recognize that this is the Pythagorean identity. And it is equal to sine squared. So you could do the integral as 1/4 integral of sine squared 2x. I'm not going to go that way. I'll pretend that I didn't see it. Let's say that you're in the middle of the exam, and lots of times when we're in the middle of an exam, we don't see things. So if we don't see that, what do I do with a cosine squared? I do the same thing. As long as there is a cosine squared or sine squared, I can use the double angle formula to simplify it. This part here is equal to 1 plus cosine of, well, double the angle now, so it's 4x divided by 2. Right? Common denominator. 2 minus 1 is 1, so I have 1/2. And then this minus sign distributes in there, so now it's minus cosine 4x over 2. I factor out the 2 on the outside, so it now becomes 1/8. Integral of 1 is x. Integral of cosine is sine, 4x, and over 4 plus c. You can leave it like this, or you can multiply the 1/8 in. I'm going to leave it like that. Alright, so in summary, this is how it works. For any even power, you separate out the cosine squared or the sine squared, and then you use the double angle formula to make the square go away. Eventually, all the even powers will be gone, and all you have left are a bunch of odd powers. And with odd powers, if it's just power 1, like the two examples we've seen, then you just integrate directly. But if it's like power 3rd or power 5th, then you use the method of part 1, where you separate out one power and go from there. There's a special case of the even power thing, is when both sine and cosine have equal power. And we only do this if it's equal and even. If it's odd, we'd rather do it like part 1 and do the odd power thing. So if they're equal and even, there's a shortcut using the double angle formula of sine. Let's go back to the same example as before, but this time we're going to use the double angle of sine. Integral of cosine squared, sine squared. This can be written as integral of cosine sine quantity squared, like this. I'm going to apply the double angle of sine formula, this formula. And if I divide both sides by 2, then I end up with a formula that transforms cosine sine into a single sine. Different angle, but still single sine. So applying this here, I have sine of 2x over 2, quantity squared, like that. And I can factor out the 1/4. I have sine squared. What do I do with sine squared? I do the same thing as before. Double angle formula of cosine. Sine squared becomes 1 minus cosine of double the angle. So now it's 4x over 2. And then I still have the 1/4 on the outside. I'm ready to integrate, actually. There's nothing complicated about this integral. The denominator, I'm going to take the 2 on the inside and multiply with the 4 on the outside, so I have 1/8 on the outside. So I don't have to worry about the denominator. I'm integrating the numerator now. Integral of 1 is equal to x, and integral of cosine is sine, and plus c. I could expand this out by multiplying the 1/8, or I can leave it as is. I choose to leave it as is so that you can compare with the result in the previous part and see that they are identical. I got the identical result a little quicker than before. So in summary, if you have equal power sine cosine, you can take the cosine sine and apply the sine 2x formula to it and simplify the integral. In practice, we don't usually bother with this when the power is odd. We only bother when the power is even. but it works for both cases. All right, you may have noticed that all the previous examples, the sine and the cosine are of the same angle. What if they are not the same angle? In that case, we use these formulas. These are called the product to sum formulas, and they come from the sum of angles and difference of angles formula for sine and cosine. And when you play around with the algebra on them, they become these formulas. To be honest, I never remember those formulas, the product to sum formula. I always derive them from scratch, from the sum of angles and difference of angles. So you may want to look back at your trig notes to see how it's done, because you probably don't want to have to memorize too many formulas. Let's apply those formulas to this integral. This integral is an integral of sine times cosine. So we're going to look up the formula, and we see that the applicable formula is this one. I'm going to write it up here. So in this case, this is A is 3x, and B is 5x. I use this formula, so it's equal to 1/2 times sine of A minus B. 3x minus 5x is negative 2x, plus sine of 3x plus 5x is 8x dx. I'm ready to integrate. Everything here is normal. So 1/2. Integral of sine is negative cosine over the negative 2, plus integral of sine again is negative cosine. All right, this negative and that negative cancel. Cosine of negative 2x is equal to cosine of positive 2x. So that negative cancel also. Yeah, cosine is an even function, where sine is an odd function. And because tangent is sine over cosine, therefore tangent is also odd. So those are some little trig facts that you also need to know. Now it's just simplification in terms of algebra. I have cosine of 2x All right, the last thing I want to talk about is, you may be wondering why I'm not writing 1/2 c. Because c is an arbitrary constant. If I divide by 2, it's just a new arbitrary constant. It's arbitrary anyway. For example, if I arbitrarily cause c equals to 100, then 1/2 c is equal to 50. Well, that's also arbitrary. I could have just arbitrarily called it 50. Because it's arbitrary, I don't need to write 1/2 c. It's just a new c. And that's the final answer to this question. So summary for part 4 is, if you have product of sine, cosine of different angles, use the product to sum formula to separate them out into sums. And once you have that as a sum, then it's easy. Integral of a sum is just like integral of one thing at a time. So here's a summary of all 4 parts. Part 1, Part 2, Part 3, and Part 4. There we go. Hope that helps. Like, share, and subscribe for more contents. And thanks for watching. Bye.